Okay, Andy. Good morning, everyone. Online friends, can you hear my voice? Say yes or no to me once. So, online friends, can I hear my voice? Okay. So, we are entering into third concept known as third relation known as inner classes. Anyway, today, let me give the clarity on it. The process of declaring class inside the class is known as inner class, or you can say nested class. These inner classes are categorized into two types: member inner classes and anonymous inner classes. Member inner class means like variables, like methods, like blocks, like constructors. We are going to declare one class inside the class. We are calling it as a member inner class. The classes which are declared as members of class are known as member inner classes. These member inner classes are categorized into two types: static member inner classes and non-static member inner classes. I given the notes on static member inner class and program and I stopped. Now, the member inner classes which are declared with static keyword are known as static member inner classes. Coding rules. These three coding rules. To explain these coding rules, let me draw the diagram and I'll read the coding rules. You will understand very clearly. Okay, right. Finally, on the day, one program I written for you. This one. I took one class as a subclass one. In this subclass one, I had two variables, one instance method, one class as a concept. I declared one class inside the class with a static keyword. We call it as a static member inner class. Inside the static member inner class, you can declare static members and non-static members. That's a common. So for this, let me draw one diagram. Okay, right. Whenever I want to draw the diagram here, right, execution flow of above program, nothing but static member inner class diagram. Sir, I want to know how many class files will come. How many class files will come? I want to know. How many class files will come? I want to know. So from here, subclass 1 dot class file. Subclass 1 dot class file. Because outer class. Look here. Compiler The first stage is compilation. Compiler, one stage will be there in the compiler known as segmentation. Segmentation means dividing the program into meaningful partition. Meaningful partition is a segment. General English meaning, whenever you want to tear one book or whenever you want to divide one book, how will you divide? Sir, I'll divide the book by chapter. I'll divide it. Means chapter is one meaningful part. If not, I'll divide it by topic. So topic is one meaningful part. Roughly you should not tear it, no. Roughly I'm speaking. The same way, if a program is decoding, the compiler must see line by line and come. That it decodes, checks and combines actually. Now, in the process of decoding that program, it does segments. Segments means classes. The first meaningful partition of your program is class, because dot class files will come. That's the reason. Now here, two classes are there. One is subclass 1. Inside that, subclass 2 is there. It takes subclass 1. Inside one, subclass 2 is there. It takes that subclass 2 outside. Outside. Now two classes are there, no? Right. Subclass 1 dot class file. Subclass 2 dot class file. Look here. Subclass 2 dot class file. But the subclass 2 came outside from another class, no? So it is an inner class. It is an inner class. Inner classes in Java represented with dollar symbol. Compiler will add $1. The dollar indicates that compiler took that class as a inner class, means it took from another class dollar. Now the compiler will say that this subclass 2 taken from subclass 1, it is an inner class dollar. From where I taken, the information must be given. So it adds the outer class name, it adds. What is the outer class name now? Subclass 1. Finally, how the dot class file will come now? Subclass 1 dollar subclass 2 dot class file. The meaning, subclass 2 is the inner class of subclass 1. That's the dot class file. So main class normal only. Here inner class not available. Main class normal. Demo inner class 1. Demo inner class 1 dot class file. This is one main class. Write it and keep it, all of you. The new symbol is dollar. Dollar symbol from today represents inner class. Dollar symbol from today represents inner class. Represents inner class. Sorry. Dollar symbol in Java represents one inner class. Right, look here. Now the diagram is like this. For this, we are making one diagram. Flow. How that inner class will be loaded. Sir, we saved the program with application inner class 1. Out of this application, 3 dot class files came. Three dot class files came. Out of these 3 dot class files, we are taking the main class outside anyway. You know that concept. Here I am drawing method area where classes are loaded, heap area where objects are created, Java stack area where methods are executed. Method area, heap area, Java stack area. So main class will be loaded and the main method will come for execution. Main method will come for execution. That main method will come for execution. Your execution engine will detect this main. What is the first line available? Create object for subclass 1, line number 1. So create object for subclass 1. 1 equal to new subclass 1. Create object for subclass 1. In the process of creating object for subclass 1, subclass 1 must be loaded. So subclass 1 is loaded. Subclass 1 is loaded. So this is outer class. Outer class. The rules: while class loading, static members has to get the memories. So outer class members, A is there. Non-static. A means non-static. A. Non-static. B is there. It is a static. Outer class is static. B is equal to 20. B got the memory. M1 non-static. M1 non-static. Memory not available in the class. Now this class is static actually. So class is static. So the class will get the memory. The class will load inside the class. The class will load inside the class. Dollar subclass 2. And this is inner class. Static member inner class. Inner class. Now class inside the class, that is. Now in the dollar subclass 2, X is there. Sir, X is non-static here. X is non-static. Y is static. So Y is equal to 200. M2 is non-static. M2 is non-static. M22 is static. Void M22 is static. So this is inner class. This is outer class. So subclass 1 is outer class. Inside the outer class, inner class memory also available. Not only static member inner class. That is our visual. Now we have to create object for outer class. We have to create object for outer class because here creating object for subclass 1, no, here. So create object for outer class. So I am creating object for outer class. I am creating. While outer class object creation, outer class instance members will get the memory. Outer class instance members means A. A will get the memory. Outer class instance member means M1. M1 will get the memory. A is equal to 10. Void M1 will get the memory. So A got the memory here and M1 got the memory here. A got the memory and M1 got the memory. So A got memory in the object and M1 got the memory in the object here. So this is 1. So instance members of outer class will get the memories. Like this. So this object belongs to outer class only. Sir, what about M2 and X? They are all inner class members. This object belongs to outer class only. In outer class A, memory is there, M1 memory is there. This class is static. It is separate. So this is the object of outer class. This is outer class object. This outer class object, load it onto OB1. This is your outer class object. So whenever I call OB1 dot M1, if I call it, that M1 method will come for execution. This M1 method will come for execution. Void M1 will come for execution. Right. See there. M1 method coming from the object. M1 method can access A. M1 method coming from the object. Object belongs to outer class. Object belongs to outer class. So outer class variable B can be accessed. Outer class B is then it can access. So it can print A is equal to 10 and B is equal to 20, it can print it. A is equal to 10 and B is equal to 20, it can print. That is M1. This is over now, right? Our target is inner class. So now comes your inner class object. After this line completed, subclass 1 dot subclass 2, OB2 is equal to new subclass 1 dot subclass 2 here. Subclass 1 dot subclass 2. Class 2 OB2 equal to new subclass 1 dot subclass 2, like this. Right. Create object for subclass 2 which belongs to subclass 1. That's the concept. Dot means what now? Belongs to. So subclass 2 belongs to subclass 1. Create object for subclass 2 which belongs to subclass 1. So if we see here, diagram also that only. Subclass 2 belongs to subclass 1. It is available inside or not now? Create object. So create one object. Inner class object. While inner class object creation is going on, inner class instance members has to get the memories. Inner class instance members are X. So X is equal to 100. Void M2. X got the memory and M2 got the memory. This is inner class objects. All of you understood the diagram? Right. Okay. And now this address loaded onto OB2. Right. All of you got it? Right. Now OB2 dot M2, I'm calling a method. OB2 dot M2, I'm calling a method. Now OB2 dot M2, I'm calling. This M2 method we are calling for execution. This M2 method is coming from the object. This M2 method is coming from the object. Void M2 coming from the object. Why the diagram means for visual to the student from where it is coming. If diagram not there, the visual will not come. Where it is coming from, the student cannot understand. Where it came from, it can access there. That's the concept. From where the method came, it can access there. It came from object means it can access object. It came from class means it can access class. That's the meaning. If it came from object, it can access object. Not available, it can access class. Because object came from class. That transition only this diagram. Now M2 came from the object. Can you see this? M2 can access X. Yes or no? Right. So M2 came from the object. It can access the X variable, it can access. So X is equal to 100. It can access. Because M2 came from here. M2 came from the object. It can access the class. Inner class it can access. Because object belongs to inner class. So it can access Y. Access Y. Now see. Now this M2 came from the object. And it can access inner class. From inner class, it can access outer class. Y means inner class belongs to outer class. It can access. Meaning is M2 belongs to object. Object belongs to inner class. Inner class belongs to outer class. It can reach up to outer class. In outer class, one variable is there, no B. It can display. So it can display the B also. It can display the B also, it can display. All of you understood up to here? But M2 cannot reach outer class object. It cannot reach here. M2 method cannot reach to that object. Whenever you want to travel from one object to another object, whenever you want to travel from one object to another object, there must be relation between the two objects. Relation means what kind of relation? References. One object must hold the reference of another object. Then only you can travel from one object to another object. But here, no object is holding the address of other object. So there is no relation between these two objects. These two objects are not interlinked. Because of this reason, M2 cannot travel to access A. M1 cannot come to this X. The two cannot use it. That only coding rule here. See there. Instance methods of. Here instance method means M2. The instance methods of static member inner class cannot access instance members of outer class. Instance members will be in the object, inner class object. Instance members in the outer class object. From this object to another object, you cannot travel. Not only meaning. Understand? You cannot travel because if you want to travel, relation must be there, but a relation not available. Instance methods of static member inner classes cannot access instance members of outer class directly, but can access static members of outer class directly because the method came from object. Object belongs to inner class belongs to outer class. Accessing why no? Right. All of you understood this? Says or no to me? That's a coding rule. Diagrams are our visuals. Example, if I speak roughly, your mind will not work at it. Because we are in the starting stages, no? Sir, where I should imagine it, sir? For me, thinking not coming, sir, the student will say. At least one diagram, if I try, it is available there. We are going and accessing, we'll show it means of that one diagram. From day one onward, there's the visuals. Total, all visuals I am drawing and coming. Today, one static member inner class visual means what? Developer will visualize. If anybody is speaking in the interview or part of project, if anybody says, I'm using static member inner class, the diagram visual should come. Static member inner class memory, inside the outer class will be there. It's a concept. If any instance method available in the static member inner class, it cannot access the instance variable of outer class. That idea should come. All of you got this point, right? See, the output is X, Y, B will be there. In the output, you can see X, Y, B is there. but A is not available. All have understood this? Right, okay. So this method destroyed. I am calling the static method directly. M22 belongs to subclass 2. Subclass 2 belongs to subclass 1 here. Subclass 1 dot subclass 2 dot M22. I am calling the method from the class directly. So control will go to class directly. The control will go directly and M22 belongs to subclass 2. Subclass 2 belongs to subclass 1. The search goes to subclass 1. Inside that subclass 1, subclass 2. Inside that subclass 2, M22 is there. That M22 will come out. Method came here. Now the method came from the class object. Now the method came for execution from class or object. It can access the class only. It cannot access object. So M22 can access the inner class variable Y. What it can access now? Y it can access. Inner class variable Y it can access. M22 can access inner class. If not available, can come to outer class because inner class belongs to outer class. It can access P also. It can access P also. But it cannot access objects. So object members, it cannot access because I written here. Static methods of static member inner classes can access only static members of outer class and inner class. On that day, I cannot draw the diagram now, so I dropped it. So today you got the clarity? Right, okay. So that is your diagram. Inner classes, very powerful component. This is the visual, static member inner class visual. I'll comment here for document purpose. Static member inner class. This is the diagram you have. Diagram. Right. All of you understood the diagram? See, class is means what? A class. A class can hold a static variable, static method, static block, static class. That static consider not available no. Anyway, in the class level, one variable can be there, one method can be there, one block can be there, one class can be there. It's a concept. One class also can be there. Right. Now go forward. This is a diagram I'll paste here. Right. Note, NOT note. One small point here. In static member inner classes, there is no relation between objects, which means outer class and inner class objects are not interlinked. Not interlinked. There is no relation between them, not interlinked. Right. Right. Now comes non-static member inner classes. The member inner classes which are declared without a static keyword are known as non-static member inner classes. The member inner classes which are declared without a static keyword are known as non-static member inner classes. These non-static member inner classes are categorized into two types. These non-static member inner classes are categorized into two types. Instance member inner classes and local member inner classes. One is outside the method, one is inside the method. One is outside, one is inside the method. Instance member inner class and local member inner class. The non-static member inner classes which are declared outside the methods are known as instance member inner classes, or you can say object member inner classes. The non-static member inner classes which are declared outside the methods are known as instance member inner classes or object member inner classes. Coding rules. Instance member inner classes can be declared with both static and non-static members. Instance member inner classes can be declared with both static and non-static members. The instance members of instance member inner classes can access all the members of outer class directly. The instance member inner classes can access all the members of outer class directly. Outer class directly. All members means all instance and static directly. Because inner class object will hold the reference of outer class object. The instance member inner classes can access all the members of outer class directly because inner class object will hold reference of outer class object. Means two objects are interrelated. There is a link between the two objects. Third point common about your static members. Static members of instance member inner classes can access only static members of outer class and inner class. Syntax of object creation for instance member inner class. Syntax of object creation for instance member inner class. Outer class name dot inner class name OB equal to outer class object name dot new inner class name. Outer class object name dot new inner class name. It's a new syntax. Right. Draw one box and add this if possible. That syntax. So example. Right. See there. Application inner classes 2 I am taking. Inner classes 2. Subclass what? Same type of program and same program. Public int A is equal to 10. Public static int B is equal to 20. Public void 1. Outer class M1. This is common. So we are taking instance class, subclass. This is instance member inner class, which can be declared with both members. It can declare. So static member, non-static member, method also, void M2. So system.out.println inner class instance M2. System.out.println outer class value A. It can print A directly. Outer class value B, it can print. Like this. So M2 can access all the members. So instance method can access the instance members of instance member inner classes can access all the members of outer class directly. Even instance members also can be accessed. Instance member access coming means there is a relation between the objects. The concept. Now, if you take a static, suppose inner class static M22, if you take it. This, it can access only static members, P and Y. So this is difference between first model and this model is static member inner class means instance method can access only static member of outer class because it is sitting inside the static class. Suppose the class is instance member inner class, instance method inside the instance member inner class can access all instance members of outer class. It can access. Not only one difference. Now create object. So instance members belongs to class or belongs to object? Belongs to object. Whenever you want to create object for instance member inner class, you must refer with object name. Instance variable means ob.a. Instance method means ob.m. Instance class means ob.class name. So that only syntax here. Okay, right. Now go for main class. Demo inner class. Demo inner class 2. Here. Subclass 1 ob1 equal to new subclass 1. So this is outer class object ob1.m1. You know this already. Outer class method call. Now I am creating object for inner class. Subclass 1 dot subclass 2 ob2 is equal to ob1 dot new subclass 2. Create object for subclass 2 which belongs to ob1. That's the meaning. Create object for subclass 2 which belongs to object because it's instance. So this is instance member inner class object ob2 dot m2. So inner class instance method call. Subclass 1 dot subclass 2 dot m22. So this is inner class static method call. So answer will come. We followed the rules, answer is coming. First output, this output is, this is common here. One a variable will come, not only difference. So I'll draw the diagram and side by side I'll draw. I'll show the difference, how it happens. So here output. So P1, I took subclass 1 dot Java. P2 demo inner class 2 dot Java. This is one main class. Now let me explain how the object is created and how this instance method is accessing the instance variable of outer class. How it is accessing, let me show the diagram. execution flow of above program. Our target is instance member inner class is our target. Instance member inner class is our target. Class files same. Subclass 1 dot class file outer class. Subclass $1 subclass 2 dot class file. This is inner class. Demo inner class 2 dot class file. This is main class. We had it. So instance member inner class location, I want it. Right. I'm drawing one diagram here. Same. Application inner classes 2. After compilation, you'll get yes. Anyway, method area. If you look my material, you'll understand. Of course, you are looking in a mobile phone, I think. If you see the document, you'll understand. Each chapter, first diagram, these three will be there. Method area, heap area, Java stack area. That flower will be there. You can check it out, document. Method area, heap area, Java stack area. Method area, heap area, Java stack area. Anyway, main class will come and we are not drawing the main class. So main method will come. Main method will come for execution. Main method will come. Anyway, execution engines will come. Create object for subclass 1. Same flower. Subclass 1, OP1 equal to new subclass 1. Why I'm drawing the same thing means now you have to see where the class loaded you have to see. Previously it is a static class, now it is instance. So now new subclass 1. New subclass 1. Subclass 1 must be loaded. Subclass 1 loaded. Outer class. In subclass 1 instance members. in subclass 1 instance members. A is instance. A, no memory. B is instance. Sorry, B is static. Now, where is that? Now, M1 is instance. Now, class is instance or statica. Instance, no memory. No memory in the class. Sir, dollar. Dollar subclass 2 memory not available here. Previously, subclass 2 memory is available in subclass 1, but here subclass 2 memory not available. Now create the object. This is outer class. This is outer class. For this object created, outer class object. While object creation, instance members has to get the memories. Sir, A will get the memory. M1 will get the memory. All of you, up to here clear? Right. Now class will come. Subclass 2. Subclass 2 memory should come in the object. The rule that only. But against JVM architecture rule, you are a member of object. You must get a memory within the object. But we cannot give a memory there because class no. Class means class location separately. So what algorithm will do? Algorithm says that here actually subclass 2 should come as an inner class. Subclass 2 should come here. Subclass 2 is a member here. But memory not available here. Memory will be here. We load separately. Dollar subclass 2 class. This is inner class. Your inner class. And you are part of this. You are a member of that. All of understood is fine now, right? Memory not available here, but you are a member of my object only, but the memory is outside for you because you cannot sit in the heap area. You must sit in the method area only. From there, we establish one link to you saying that you are our member. So memory is outside. Now subclass 2 members are available now, right? X, no memory. Y, memory is there. Now M2, memory not there. M2, memory not there. M22, memory is there. Now, instance member inner class is outside, but referred by the object. It is referred by the object, the concept. All of you understood this? Right. Now, once object creation completed, this address available on OB1. The meaning of the diagram is inner class is the member of object, means referred by the object. Referred means you can access. Access by the object. So meaning. Access means entry. Through that object you can enter. Now, OB1.M1 common. OB1.M1. Major our identification is how inner class instance member coming to outer class object. That we are trying to observe here. Further on diagram is coming. So M1. M1. M1 came for execution. So M1 came from object, it can access A. The object belongs to outer class, it can access B. Okay. It can access A and B. Okay. Now, after this one, here, subclass 1 dot subclass 2. OB2 is equal to OB1 dot new subclass 2. Subclass 1 dot subclass 2. OB2 is equal to OB1 dot new subclass 2. Right. Create object. Create object for subclass 2, which is member of OB1. That's the meaning. So now control will go to OB1. In OB1 it checks, yes, you are a member. I have to create object, but memory not here. Memory is here, no? Right. Anyway, you are a member, I'll create an object. So object creation started. Right. Very important point. So here, subclass 2 is member of OB1. Subclass 2. OB1 dot new subclass 2 means subclass 2 is the member of OB1. So now we are creating object for subclass 2. One subclass 2 object created. One object created. So subclass 2 is the member of OB1. Subclass 2 is the member of OB1. Means what? OB2, OB3 is the member of OB1. OB1 or OB2? OB1 is right, 0x2. Correct only. So now when the subclass 2 is member of OB1, then subclass 2 object is the member of OB1. When subclass 2 is the member of OB1, subclass 2 object also member of OB1. Because of this reason, your algorithm will say that I'll bind the address of outer class. I'll bind it. Sir, why this address is binded there? The reason, the members of inner class can access outer class. The members of inner class can access outer class. Because inner class object holding the address of outer class means inner class object is the member of outer class object. Inner class object is the member of outer class object. The address is binded here. The theory is subclass 2 is member of OB1. Then subclass 2 object is also member of OB1. Then subclass 2 object must access all the members of OB1. Then subclass 2 object must hold address of OB1 to access. That's what the algorithm says. The address is binded. Once address has been binded now, here, X will get the memory. And M2 will get the memory. X got the memory and so inner class object holding reference of outer class object. This address available on OB2. Sir, what is the proof? The address is available there. What is the proof now? I'll call this M2 method. I will call it OB2.M2. I'll call the method. Whenever I call the method here, this method, I'll call this. Void M2. Right. Now see. Very important point here. Now M2 came from the object. M2 came from this object. M2 came from here, no? Right. This M2 can access X. Yes or no? Now this M2 can access Y. The reason? The object belongs to this class. This M2 can access A. How? Using this address. Here one address is available or not now? Using this address internally, it can come here. Now M2 can access A directly because internally address and link is there. Now this M2 can access B. Sir, how it is coming to B now? When it come here, it can go here. It is accessing all the locations or not now? Observe that, right? It's called your algorithm will keep the address. Rule that only. Subclass 2 is the member of OB2. OB2 or OB1 now? OB2, OB2, OB1, OB1, I'm a bit confused. Subclass 2 is the member of OB1. Then subclass 2 object is the member of OB1. When subclass 2 object is the member of OB1, all the members of subclass 2 object must access all the members of OB1. If you want to make it access, address should be binded. So internally one algorithm will activate and it will bind it. So this is very less people knows. Internally one address is binding. Very less people will visualize. So finally, it can access A, B, X, Y. All it can access directly. It has access to all directly. A is equal to 10, B is equal to 20, X is equal to 100, Y is equal to 200. So everything it can access. So that only your answer also. A, B, X, Y, all it can access. That only written here. Instance methods. The instance members of instance member inner classes can access all the members of outer class directly because inner class object will hold reference of outer class object. So, last one. Subclass 1 dot subclass 2 dot M22. So this is common only directly. Directly the access available here. The last batch people, so one person, sir, I am absent, sir. Can you explain this diagram again, sir? It's not possible. And I also will forget it. While I'm this many arrows, I also cannot remember. If I want to explain again, I should draw. For me, I cannot remember. For me, not possible. Frankly, for me, short-term memory loss will be there. I cannot remember. Whenever I take a concept, I'll be in that concept only. Because of this, sometimes these people will not make any noises. I know. Sometimes if anybody disturbs me, I'll scold it. Not only you, in all the batches. Of course, nobody will disturb me. Why means we are actually, I'll be looking. I will not look your faces at you because I'll be thinking my term. Because we are all live code writers and live concept delivers. Like your school teachers or graduation teachers, we never write notes and come. That trainers will write notes, no, for us not there. Directly we are enter. We'll take one concept and explain and go. So in that instance of time, whatever the ideas we get it, we write and go. So we are all live code generators, live code delivers. Even advanced also that only. Even we'll take a concept, we'll write the project and go. Unless Amirpet, we cannot survive. That subject not that we cannot survive. If not, if I can prepare daily, here 6 hours, there 6 hours, I must write. Because of this reason, we'll take one concept. Again, if you ask me, I cannot remember. Again, I must put myself into that subject. Again, I must drag myself into subject. Moreover, I'll be changing the subject. Morning, one topic I'm running. 10 minutes, I'll take a breakfast and I'll sit there. I'll see the mobile phone, some news I'll see like this. I'll take one cup of coffee, I'll come. I'll see the date and the topic I'll see. The topic I'll see, I'll scroll. Observe daily, I'll scroll up and down for 5 minutes. I'll scroll it. I'll adapt the concept and I'll start it. Now I'll close the system. I'll go to Advanced Java, 11 a.m. Until I go there, I don't know what is the topic running. I'll go there and I'll scroll the system again, up and down, I'll scroll it. Again, I'll remember that, I'll continue. Again, 2 p.m. Advanced Java. Like this, 4 p.m. one topic, 6 p.m. one topic. So until I open the system, I cannot. Moreover, At home, if I notes I have not uploaded means I will not upload. Tomorrow morning I am sitting here, I'll upload. Observe or not now. Again, if I open the system by 9 a.m., I cannot remember you first. What is happening? I must search the file. That much of patience will not be there. Again, whenever I come to the class, your files, your documents, I'll remember it. Immediately I'll copy it and I'll start the class. Again, once I not loaded by 1 o'clock means I will not load. Sometimes I'll load by 8 o'clock. Not load, I will not load because I will not remember first the reason. Here also, don't ask me again, sir, please explain this diagram once again, sir, means not possible. So I am also drawing only once here. So I am 2, not possible. So M22. Void M22. Give like this. It can access only static members. It can access. It cannot access non-static. See there. It is coming from the class. It can access Y. It can access B. Sir, how it access B? Here dollar symbol is there, no? So it knows I am the inner class of another class. I'll go to the class directly. The algorithm given permission to access B. So here Y will come, B will come. So B is equal to 20 and Y is equal to 200 will come. The point. Right. All of you understood this diagram? Says or no to me? Right. If you see these two diagrams side by side there, see it. I drawn the same color, you can understand. I given reverse color, right. There one inner class is there, no? Right. That inner class is inside the class there. Subclass 1 holding inner class. But the inner class is outside, but linked to object. So it is acting as a member of object here. So whenever I want to create object, I'll say OB1 dot new subclass 2. Means create object for subclass 2, which is the member of OB1. So automatically the object of subclass 2 will hold the reference of OB1. It's a concept. The two objects are interlinked. These two diagrams are side by side. Total inner class flavors are two diagrams only. One is instance member inner class. One is static member inner class majorly. I'll comment here also. This is instance member. The two diagrams, I'll paste it for you in a document. So after that, make a statement, note, NOT, note. In instance member inner classes, the inner class object will hold the reference of outer class object, and the objects are interlinked, or you can say interrelated. Interlinked or interrelated. So these two programs, two diagrams you have to watch again, and after that do one assignment and come. update above applications by initializing variables using constructors. Initializing means loading the value for a, b, x, y using constructor, means reading from the keyboard, loading the data by using constructor. About two programs, two, x, y, a, b, in both the same program only, but only static keyword not available. Load the data to a, b, load the data to x, y by using constructor, reading from the keyboard. So try it. First you have to read this topic, understand the topic, then add constructor and come. Tomorrow I'll make a revision on the two models, and this solution I'll give for 10 minutes, and I'll go for local inner class. Local inner class means inner class will come inside the method. It is coming inside the method. Inner class will be inside the method, it will come. So the inner class inside the method, we call it as local inner class. Tomorrow I'll introduce that local inner class. From there we go for anonymous. Anonymous is without name. Tomorrow two models will come. Local inner class will come. Anonymous inner class also will come. Through anonymous inner class, assignment will come. That's the point, right? So practice this and come for today, right? Take a break. Thank you very much for today. Last class notes I given, no? Advanced Java? Advanced Java notes loaded to you. That only will have. I said no, short time memory loss will be there. I'll correct it. Okay.